This is 1 over 10 cubed, which is 1 over 10 times 10 times 10, which is 1 over 1,000, which is 0.001. Okay, so that's why that exponent works. Any questions on that? All right, very good. Thanks, Chris. Okay, D, how about D? How about Andrew? What do you think this is, Andrew?
Well, wouldn't it just be because there's the 5 and then the log 5, wouldn't it just equal square root of 3?
Yes, that is correct. Okay. So what's the power that goes on 5 to give you square root of 3? Well, that's it. It comes out to be square root of 3. Okay, so when these bases are the same, then you get what's inside the parentheses. Okay. All right, how about this one? How about Layla? Excuse me. What exponent will go on that?
11.
This is what I'm asking. What exponent goes on square root of 11 that will give 11?
1.
That will give you square root of 11. How do we get rid of the root?
You put a 2.
2, you're going to square it. Okay. So if I put a 2 on square root of 11, that's going to give me 11. Does that make sense?
Yeah.
2 here. Okay. Now the last one is the most challenging. So who would like the most challenging one? I'll open that up for a volunteer. What brave soul would like to take it? Basically asking 27 to what power will give me 9?
Wouldn't it be 2/3?
Yes. Who was that? It said it so quietly.
Oh, it was me. Sorry, Sabrina.
Sabrina. Hi, Sabrina. Okay, 2/3. Let's check that out. So if I have 27 to the 2/3, that's the cube root of 27 squared, which is 3 squared. I don't know why I can't write 2, which is 9. So yes, this is 2/3. Okay. All right, you guys, that's all fair game for the quiz this week. You will get probably one of almost all of those. And there's another one coming up later, maybe I didn't cover here. All right, for number 2, you have to isolate log. That is the first thing to do. Okay, so that means I should subtract 1, and I get 4 log base 7 of 3x minus 2 is equal to 8. And then we have to divide by 4. So that log base 7 of 3x minus 2 is equal to 2. All right. Now, once you do that, we're going to use our definition. Okay. So this means 2 is the exponent that goes on 7 that will give the stuff inside. Any questions? You cannot solve this with log part of the equation. You have to isolate log and rewrite it with an exponent. Now, this is just a straight regular equation. I'm going to add 2. So 51 is 3x, divide by 3, and x is 17. Any questions there? All right. Last one is domain. So I put this number in front here, but it really has no bearing on your domain. The domain is just what you're plugging into the function. So this is this part. I'm looking at my input. And my input has to stay positive. So I have to find all the x's that is going to make 7 minus x stay positive. So if I add x to both sides, that means 7 is greater than x. This is the same as saying x is less than 7. Okay, same. And in interval notation, That means from negative infinity to 7. Any questions? So if I pick any number less than 7, so like 6, 7 minus 6 is 1. That's fine. 7 minus 0, 7. That's all good. All right. All right, so here we go. 9.4. We're going to talk about the properties of logs. Okay, the properties of logs. And these things are really, really useful. We're going to use them a lot. You have to know them. You need to memorize them. So must memorize. You will use a lot. All right, so for any positive numbers, I'm going to say X, Y, and A. Okay. We have 3 things that we can look at. The first is called the product rule. And the product rule says that if I have log base A of 2 things multiplied together, I can expand this into log base A of X plus log base A of Y. Okay, we can take 2 things multiplied together on the input and break it up into an addition problem. All right, 2 is something called the quotient rule. Now, if I have a fraction, which is a quotient, this is the same as saying log base A of X minus log base A of Y. Okay. And then the last one is called the power rule. Which says that if I have log base A of X to some power Y, this is the same as saying Y times that log base A of X. And these go in opposite order too. These properties work both ways.
What does that mean?
Let me put it this way, work in both directions. Meaning, like, for example, if I have Y times log base A of X, I can write that. I can take that number, that Y in the front, and I can put it up as an exponent. Okay, so it doesn't matter, like these are equivalent. And we're gonna practice using those right now. So here's examples. Okay, find the exact value of each. So here's A. Let's find log base 2 of 16 times 32. Now, 16 times 32 is a really big number. So what we can do here is inside we have a product, so we can use that first rule to break it up into an addition problem. Okay, so let's do that. So I'm going to rewrite using product rule. So this is log base 2 of 16 plus log base 2 of 32. Okay. And what this does is the exponent that goes on 2 that gives me 16, we know is 4. And the exponent that goes on 2 that gives me 32, which is that one. 5, which is 9. So that's 9. Now, if you multiply 16 times 32, what that means is that 2 to the 9th is that number. Well, that's a really big number. So this is one example of how the properties kind of help us break things down into easier numbers to use. All right, here's B.
Can we do it the reverse way too? So if it's like a really big number, can we like separate it?
What do you mean? Give me an example what you're thinking.
So say we have like a really large number and then we separate it into x times y. Like do it basically the opposite way, like flip it.
Okay.
And-
What you have to be careful about is that what I just did, like, so I started off with it as being multiplied, but yeah, if you had the bigger number and you factored it, yes. Okay. What you have to be careful, I'll put a warning over here. You cannot say this. Log base 2 of 16 times log base 2 of 32 is not equal to log base 2 of 16 plus 32. So you have to be really careful when you use these, that you use it in the proper way. The inside of the log has to be a multiplication problem, and then you break it up into addition. But it's not like, you just have to make sure you don't do it this way. So that's why I asked you, because I wasn't sure, like, what, I want to make sure you don't do it the wrong way.
Yeah, thank you.
All right, let's try this one. Log base 2 of 16 over 32. Okay. If I use this is my quotient rule. I can do log base 2 of 16 minus log base 2 of 32. Okay, so that, if I just look back real quick, that's my quotient rule right here. I'm breaking it up using subtraction. And it always goes in the order top to bottom, left to right. It follows that order. Okay. So this is going to be 4 minus 5, which is -1. So note, I want to just show you guys also that sometimes there's more than one way. In fact, a lot of times with the properties, there's more than one way to do it. Something like 16 over 32. What fraction is that really?
Half.
A half. Okay. So what if I simplified 16 over 32 to a half? And then what's the exponent that goes on 2 that'll give you a half? -1, right? 2 to the -1 is 1/2. So that's my exponent. So you guys see, like, sometimes there's more than one way to do these, and that's okay. Both of these would be valid. All right, so let's practice now. Write each of the following as either a sum, product, or difference. So basically what I'm going to do is I'm going to expand using the properties as much as I can, okay? So let's start with, just start off with something really basic. Log base A of q to the 7th power. Okay. Now I want to write this. I'm going to expand it out. So which property is this? Am I using the power, the quotient, or the product?
Power.
Power. Definitely power. So what I can do is I can kind of like parachute that exponent right out in front. And this is the same as saying 7 times the log base A of Q. And now I have it written completely as a product. Okay, any questions? Because I'm gonna.
Is that the final answer?
Yes. There's nothing more I can do. You keep going till you can't use any more of the properties. Okay. So now let's do one where you combine properties. Let's do one like this. Log base A of P squared times Q. So I can't parachute that square because it's not on P and Q. Okay. Notice this is different from, it's not this, right? That's different. This is P squared, Q squared, okay? So the first thing I'm going to do is look at that product, P squared times Q. That can be broken up into addition. So this is going to be log base A of P squared plus log base A of Q. Oops, messy Q. Okay. Now I look and see, okay, what other properties can I use? Well, I can use the power one. I still have that exponent. So let's bring this down. And this is going to be 2 times log base A of P plus log base A of Q. And then if you look at each of those, there's nothing more that can be done. It's completely expanded out. It's all like sum. There's a sum and there's a product, but I can't do anything else. Any questions there? All right, let me have you guys try one, and I'm gonna log base A of P to the 3rd over square root of Z. I want you guys to give that a shot first. See if you can figure out how to expand it using all your properties. And you should be noticing now, so note, you do powers last when expanding. Do the power rule last. Okay, so your first step here should have been to do the quotient rule. So it's log base A of P to the 3rd minus log base A of square root of Z. Make sure you include your base, and it has to be the same base in both cases. And now we're going to take care of, I can do this exponent. This will be 3 log base A of P, 3 times that. Now with the square root, you can do one more thing with this. You should do one more thing. You have to recall or remember, what is square root of Z with an exponent? Z to the 1/2. So this is really minus log base A of z to the 1/2. So that means that we can bring that down. So 3 times log base A of P minus 1/2 log base A of Z. And that's as far as you can go. Any questions there? All right. Last one, log base A of x y to the 4th divided by 3 times the 4th root of 7. Okay, this has got everything in it. Everything we could possibly want. So we're going to start with the quotient. We're going to take care of the quotient. Then we're going to take care of the products. And then the last thing will be the exponents, the powers. Okay, so this is log base A of x y to the 4th minus log base A of 3 4th root of 7. Okay, now you should see inside there, each of those is a product. You guys with me? So this is log base A of x plus log base A of y to the 4th minus log base A of 3 plus log base A of 4th root of 7. Now, the only thing is you have to be careful because I'm subtracting, I said minusing. I'm subtracting that entire quantity. So you do need parentheses there. Make sure. Parentheses are necessary. Okay. All right, I've taken care of the quotient, the product. I have some powers here. So log base A of x, that can't change. That's all they can do. I can bring down this 4. So this is 4 times log base A of y minus, now I'm going to distribute this negative, log base A of 3. And this is going to be minus, now this is 7 to the 1/4. So it's going to be 1/4 log base A of 7. And that is my final answer. Questions? I kind of skipped a step here, so let me just be careful. Probably most people are okay, but I just move this down. I just want to make sure this is really clear. Okay, so if you're wondering where that 1/4 came from, it came from that root. Okay. Any questions? All right. Now we're going to practice going the other way. This is what I was talking about. Instead of expanding, we're going to condense it into one log. So let's do some of those. So express as a single logarithm. All right. Let me just do a little mental check-in right now, see where you guys are at. All right. Using your emojis or whatever, why don't you give me, how was your Thanksgiving? There's clapping, there's thumbs up, there's heart, there's laughing, there's oh no, and there's party symbol. Tell me guys, just using your symbols, Thanksgiving, a lot of thumbs up, okay? Clapping, party, all right, sweet. Micah, oh, Micah. All right, hilarious. Okay, good, all right. All right, back to here. So let's do this one. I'm gonna 1/3 log base 4 of x squared plus 2 times log base 4 of, this is a 4, y to the 5th. So I'm not messing around because I got to get to some other stuff. I want to make sure we have enough time. So I want to condense this to 1 log. All right. So now when we go in reverse, powers are now first. Okay. So when you're expanding, it's the last thing you take out, like you work with. But here we need to put our powers up first. So this is log base 4 of x squared. And I'm going to bring this 1/3 up as a power. And then this is y to the 5th, and the 2 goes up as a power. Now we have to remember what our rules are with exponents. If I have a power raised to a power, what do I do with them? What do I do with that 2 and 1/3? And everybody said all together at one time, we multiply. Okay, so this is log base 4 of x. 2 times 1/3 is going to be 2/3. Okay, plus log base 4 of y to the 10th. Now, see how I wrote that? The one I put inside the parentheses, the other I didn't. It doesn't matter. Once you have the exponent up and it's like just a single term, you can put it in, out. It's the same thing. Okay. All right. So now that I took care of the exponents, nothing else is around the log. Now I have to take care of that addition. So what does the addition say I can do with these? What rule is this?
Multiply them together.
The
Multiply them
product.
together. Yeah, we're going to do the product rule. So I'm going to bring these together into 1 log as x to the 2/3 times y to the 10th. And I'm just going to leave it like that. You don't have to rewrite that as a root. It's fine just the way it is. And that's it. There's nothing else I can do. I brought everything together into 1 log. Any questions? All right, here's example 2, and I'm going to let you guys give this one a whirl. So bring this together into 1 log. 3 times log of x squared minus 1/5 times log of x to the 10th. Give you a head start. Okay, so the first thing was you should have moved those numbers in front up as exponents. And then we multiply them. And then what would we do? What can we do next? Make them what?
The quotient rule.
Quotient.
Don't worry.
Yes. So this is x to the 6th over x squared. So if you got that, good. Now, if you didn't know, we can also simplify. So this would be 6 over 2 is x to the 4th. So this is completely simplified. And what this means is if I picked a number for x, like I want you guys to understand, if I picked a number for x and I raised it to the 4th power and then I took the log of it, that would be the same as doing all these steps. Okay, that same number squared, log it times 3, minus that number to the 10th, log it times 1/5. Okay, like these are the same things. Like if you were to plug in numbers for x, you would get the same output. Okay.
So if we left it as x6 over x2, would that be wrong?
I would want you to simplify it. You should simplify.
All right.
Yep. All right. So now what we're going to do is we're going to do these properties, but with numbers, and you're going to have to be clever at times. Okay. So I'm going to give you some information. Use the approximate values. And we have log base 7 of 4 is equal to 0.7. And I also am going to give you that log base 7 of 20 is 1.5. To find the following ones. Here's A. A is log base 7 of 4/7. B is log base 7 of 16. And C is log base 7 of 25. So 3 different possible things here. Okay, so let's just focus on A. I wrote it like this because I don't want to lose sight of what values I gave you. I had to scroll back and forth a lot in my last class. It was kind of annoying. All right, so looking at part A, what property stands out to you? You're like, oh, I should use the what property?
Quotient.
Quotient, okay? I have a fraction. And again, don't get paralyzed. Sometimes you have to try something and just kind of see where it goes and then reassess and make different decisions, which I know you guys hate as students, but that's the way it is. So I'm going to try the quotient rule and let's see what that gives me. This is going to be log base 7 of 4 minus log base 7 of 7. Okay, now the thing about these values is that you can only use them once you have, you need to have log base 7 of 4 be exactly in that form. Okay, you cannot, I just want to point this out. So warning in red, my warnings always try to go in red. Warning, okay? Log base 7 of 4/7 is not log base 7 of 4 over log base 7 of 7. Okay, not true. So you can't just say, oh, I can do this. No, you cannot. You have to use your properties. That is not a true property. If I were to do 4 divided by 7, if you punch this in your calculator, okay, 4 divided by 7, log base 7 of that, and then you try to see if it's going to equal that other thing, they will not be equal, okay? You have to use your properties. So I'm going to subtract. Now, one cool thing is I know what this is. They tell me it's 0.7. But I don't know what log base 7 of 7 is. I'm not given that. Or do I know what it is? Can anybody?
Is it 1?
What?
It is. Yes. Good, Joanne. Good. Yes. Okay, you guys, here's the thing. Here's a fact. Okay. Log base A of A is always 1 because a to the first is a, okay? So if I get log base 7 of 7, that's just 1. And then when you subtract these, you're going to get something negative, and it's negative 0.3. I'm not going to focus on you guys will have to do the decimal stuff work on your own. Any questions on that? So big key idea, use properties. And you only have 3. So this was the quotient property. All right, let's look at part B. What property do you think we can use here to get something that says either log base 7 of 4 or log base 7 of 20? Any ideas out there?
The product property.
Or
Sure. Now you can write this one of 2 ways. We could do 4 times 4. In fact, let's do that first. This is going to be log base 7 of 4 plus log base 7 of 4, which will be 0.7 plus 0.7, which is 1.4. Does anybody else have a different idea? Anybody else think something other than 4 times 4?
I thought we could do like 2 to the 4th or something like that.
Yeah, 2 to the 4th is 16, but I don't know anything about log base 7 of 2. Here's another alternate way, though. You're on the right track there, Abil. We could have said log base 7 of 4 squared. 4 squared is 16, right? And this is 2 times log base 7 of 4, which is 2 times 0.7, which is the exact same thing I have above, 1.4. Okay, so again, I will repeat this. Sometimes, many times, there's more than one way, but I have to make sure you follow your properties. Now, the next one's a little bit trickier because I have to rewrite 25 in a way that gets me either 4 inside or 20. I can't just do 20 minus, I don't know anything about this. I don't know anything about 20 minus 5, FYI. The property doesn't tell you anything about subtracting inside. I have to take that inside and either write it as a power, as a product, or as a quotient, okay? So let's start with this. That's something I can do. I can do something with this. I can write this as 2 times log base 7 of 5. All right. It's just that the problem is I don't know anything about log base 7 of 5. I'm not given information about that. So I have to rewrite 5 using 20 and 4. It also has to be equivalent. So 5 is the same as 20 divided by 4. Do you guys see that? All I did was write 5 as 20 divided by 4 because now I'm going to be able to use my stuff up here and I can rewrite this as a quotient. So this is 2 times log base 7 of 20 minus log base 7 of 4, which is 2 times 1.5 minus 0.7. And I have to kind of hurry here. So this is 2 times 0.8, which is 1.6. So there are times where it's going to take being a little bit clever, but you just have to make sure that things stay equal. You can't change that 5. That 5 still has to be something equal to it. We'll do more of these tomorrow. You might see some on your homework. Do the best you can. And I will see you guys tomorrow. Okay, bye. Thanks, everyone. Have a good day. I'll stay for a few
Bye,
minutes
have a
if you have
good day.
questions.
Bye-bye.
Bye. Anybody here have questions?
Yeah, Miss, I got a question about yesterday's or not yesterday's, last week's quizzes.
Did you do it?
Yeah. So on, I think, what was it, Tuesday or Wednesday? I did quiz 9B after it was posted.
Okay.
And that's what was posted that day. And I don't know if it was that day or later that day